All right, so we know that composite functions are when we put one function as the input to another function. And most pre-calculus students are pretty comfortable with seeing it in this form. We're going to look at what it actually looks like on a graph. So if this is our g of x function here, it's a straight line. It has a steep slope of 3, so g of x is just 3x. And it has a domain of all real numbers. It goes all the way to the left and all the way to the right. There's no domain restrictions. Now we're also going to have another function called f of x. That's going to be our outside function here. And f of x is a square root of x minus 5. So here's our square root shape that we're familiar with. It's shifted 5 to the right from the origin. And its domain, you can see there is no red anywhere to the left here. It goes all the way to the right because of the arrow, but this graph, this function, has a domain that's restricted. It can't be less than 5. The domain must be 5 or greater because we can't have a negative inside of our square root. It's not part of the domain. So here's our two functions. We kind of understand those, and now we're going to look at what happens when we compose them. What if we want to look at what f of g of x is? Well, I'm actually going to graph the composition, but I'm going to talk about how we can use these two original graphs here to figure it out. So, for example, we're specifically talking about the domain of the composite functions. So I know that this function by itself, f of x, has a domain restriction. This green function, g of x, does not have a domain restriction. But I want to know, is something like 2, which is in the domain of g of x, but 2 is not in the domain of f of x. Can I still figure out, is 2 in the domain of the composition, f of g of x? That's my question. Well, let's figure out what that actually looks like. Let's see, what if I want to figure out what is f of g of 2? Let's go ahead and presume that 2 is in the domain of our composite function. Well, let's first do the inside function. Let's first figure out what g of 2 is. So 2 does have to be in the domain of our inside function, okay? It must be in the domain of the inside function, and it is. We can figure out what g of 2 is. We go to where x is 2, we go up to our g function, and we get an output of 6. So g of 2 is 6. I'm going to replace it with 6. Now, 6 is what we're putting into our outside function, our f. And 6 is in the domain of our outside function. So we're going to go ahead and plug in 6 into our outside function, and the output we get for the input is 1. So f of 6 is 1. That means f of g of 2 is 1. That's how we kind of manipulate or kind of navigate the graphs. So we can see that 2 is indeed in the domain of our composite function. And the two things we actually need to check to figure out what the domain of a composite function is we need to check the composite function itself, and we also need to check the domain of the inside function. So let's go ahead and write f of g of x is f of, what is g of x? Well, g of x is just 3x, so it's f of 3x. And if we plug 3x as the input into the f function, we get the square root of 3x minus 5. This x input is now changing to a 3x. So there we go. Now we can see that the domain of this composite function, we need to keep our same restriction, that the inside of a square root must be greater than or equal to 0. So if 3x minus 5 must be greater than or equal to 0, that means that 3x must be greater than or equal to 5, which means that x must be greater than or equal to 5/3. So the domain of our composite function is 5/3 to infinity, and the domain of our inside function is not restricted at all. So the domain of our composite function is whichever of the two is most restriction, whichever x values work for both of these domains. And so the answer would be this one here. X is in the interval from 5/3 inclusive to infinity. There we go. So in conclusion, I think what's unique about this is it doesn't matter that the outside function has this domain restriction of x needing to be greater than 5, because x itself is not going into the outside function. X, or in this case 2, is going into the inside function, and g of 2, which is 6, that is what's going into the outside function. So the range of g of x needs to be in the domain of f of x. And just the simplest way to look at that is just by focusing here on the formula for our composite function. So we need to check whether x is in the domain of our composite function and whether it's in the domain of the inside function, but we don't need to worry about the outside function. So here is our final answer. F of g of x, the composition, is equal to the square root of 3x minus 5, and it has this domain. And you guys actually can't see that, so I will show it to you there. Beautiful. Hope that helps.